When you first start to learn GraphQL, there's a pretty good chance that your first attempt at creating a GraphQL API will have one big problem that you really shouldn't live with. Now, I bet many of the seasoned developers who start learning GraphQL will recognize the problem I'm referring to, but there's a whole lot of developers who probably won't even notice the problem because, well, the problem isn't obvious. This problem that I'm about to talk about won't give you any errors, at least not during development. And honestly, you'll probably end up with this problem because it's the result of an intuitive solution. But unfortunately, the intuitive solution is also a naive solution. So what is this problem I'm referring to? Well, instead of just telling you, how about I show you? Okay, imagine that you and I are working on a book review app that looks something like this, and we've already created the beginnings of a GraphQL API for this app. Here's a pretty simple GraphQL query that you can use with our server to fetch a set of books that includes each book's unique ID and title, and it also fetches a set of reviews for each book, which includes the star rating and the title left by the person who left the review. Now, the GraphQL server that we're about to look at has the problem I've been hinting at, but the problem isn't obvious. I mean, watch. I'll run this query and guess what? It worked. The server didn't blow up and we got an array of books and each individual book includes some book reviews. Let's go take a look at how this GraphQL server is set up, but before I show you, I've got a challenge for you. I want you to pay close attention over the next few minutes and try to figure out what the problem is with the code I'm about to show you. Okay, to start, I'm going to go ahead and simplify this GraphQL query by commenting out the reviews field and its subselection right here. Now, when this query gets sent to the server, a resolver function named books gets called, which you see right here. Resolver functions should generally be thin. In other words, as much as possible, you should avoid putting much logic in them. So is this resolver function thin? Well, yeah, it's pretty thin. It's simply returning the value you get when you call the allBooks function. Let's go take a look at the allBooks function, which is defined in the book.js file. Okay, there's not a lot going on in the allBooks function. Right here you see a SQL statement that's querying all the columns from the HB schema's book table. Then on this line, the query function is called, which will send this SQL statement to the database and return the response from the database. Well, actually, the query function does one other thing just for this tutorial. It's logging the SQL query to the console, which you'll see in a bit. Now, in a moment, we'll run this GraphQL query, but before we do that, I'm going to clear the terminal session, which is running the GraphQL server. We'll come back to this terminal in a moment and see what SQL queries get logged when we execute our GraphQL query. Now, back in the browser, I'll run this query, and as you can see, it worked. We see an array of 10 books. Let's head back to the terminal and see what SQL commands were sent to the server. Okay, well, it looks like one SQL query, which is the query we just looked at, was sent to the server, which is probably what you expected. All right, now let's expand this query to include the reviews. Now, the book ID and the title fields you see here are stored in the book table, but the book reviews are stored in a different related table named review. So to fetch these fields, another SQL query will need to be sent to the database server. Before we run this query, let's take a closer look at what will happen on the server when we include these new fields. Now, when the server receives this modified query, the book resolver gets called again, just like it did last time. But then after the list of 10 books are returned from the database, a new resolver function is called for the reviews field. And of course, this resolver has the same name as the field, which is reviews. So how many times do you think this reviews resolver function will get called? Now, keep in mind, the reviews field is a child of the book field. So it's going to get called once for each book. So in our example, it'll get called 10 times, and as you can see here, the parent book object gets passed into this resolver. Now, this reviews resolver isn't doing much. It's just calling the reviews by book ID function, passing in the book's ID. If we peek at the reviews by book ID function, we see that it's querying the HB schema's review table for reviews where the book ID is some value represented by the $1 you see here. Then on this line, you see the params constant, which is set to be an array that contains the past book ID. When the database is sent this SQL command and this array of parameters, it safely replaces the $1 with the first element of the array, which is the book ID parameter. Okay, so this probably seems pretty straightforward to you. But do you see a problem with what's happening here? To demonstrate the problem, let me clear the terminal again, and I'll execute the modified GraphQL query, and as you can see, it seemed to work. We see the 10 books, and each book has around 3 or 4 reviews. So let me ask you this. How many SQL queries do you think were sent to the database server? Let's take a look in the terminal and see. Well, at the top of the terminal, we see a query for the book table, just like we saw last time. Then we see a query for the review table, where the review is left for the book with an ID of 1. Then we see a nearly identical query for the book with an ID of 2. And then another nearly identical query for the book with an ID of 3. And if we continue to look at every log, you'd see that 10 nearly identical queries were sent to the database server. So in total, we're sending 11 queries. So is sending 11 queries a problem? Well, it can be a real performance killer for a few different reasons. First of all, the 10 nearly identical queries consumed 10 separate database connections. So should you care that 10 database connections were used just for this one part of our GraphQL query? Yep, it really should be a concern. Database connections are a pretty expensive resource, and generally speaking, most smaller and medium-sized database servers should only have a small number of connections, usually around 10 to 20. Technically, you could allow a lot more connections, but it's expensive, and it typically leads to worse database performance than allowing a smaller number of connections and just queuing requests if and when there are no available connections to use. Now, additionally, every time a query gets sent to the server, there's a little bit of overhead. For example, the database query planner has to execute once for every single query, and guess what? Often, the amount of time it takes to run the query planner takes longer than actually running the query. By the way, the problem we're seeing here has a name that you might have heard of. It's called the N+1 problem. In other words, we're having to execute one query to get a list of books, then we have to execute n additional queries, where n is the number of books returned from the first query, which in our case happens to be 10. Now imagine if we tweaked this query to include the user field, which, by the way, would need to query the user table. How many additional queries would our database need to execute in this scenario, assuming we're following the same naive approach? Well, for discussion's sake, let's say that we run the book query, which returns 10 books. Then we have to run 10 more review queries because there were 10 books. And now let's say there are around 4 reviews per book. That means we need to run 4 additional user queries for each review query, which would give us a total of 40 user queries. So we'd end up running a total of 51 SQL queries for this simple GraphQL query. Now it's important to keep in mind, most real GraphQL queries will be much more sophisticated than this one. So as you can probably imagine, the number of database queries your server might end up attempting could quickly get out of hand. So how do we avoid the N+1 problem that we're experiencing? Well, what if instead of sending these 10 nearly identical queries, we instead sent one query that looks like this? This single database query will fetch the same review data as these 10 queries, but it's only going to use one database connection, and as you can imagine, it's much more efficient. Now the question is, how do we get from the current solution of 10 queries to this greatly improved solution with one query? This is where the DataLoader library from Facebook comes in handy. The DataLoader is a small but brilliant library that allows you to perform per-request batching and caching of queries. Well, that definition probably seems a bit vague, so let me explain with a visual. Right now, the reviews resolver is directly and immediately calling the reviews by book ID function, passing along each book ID. But what if we added something in between these two functions that could be sent the book IDs, but it didn't immediately act on the book IDs, and instead it waited some small period of time collecting all the book IDs. Then after the book IDs have been batched together, an array of IDs could get sent to another function, which could create the more efficient database query we're wanting to use. So what is this thing in the middle? Well, you probably guessed, it's the DataLoader. Okay, I bet some of you are wondering how the DataLoader knows how long to wait to collect all the IDs. Well, all it really needs to do is wait one tick in the JavaScript event loop, which is enough time to collect all the book IDs. All right, let's try and use the DataLoader. In other words, let's put the DataLoader in between the resolver and the data access layer function that will actually look up the book reviews. Now, a moment ago, I said that the DataLoader does per request batching and caching, and I want to draw your attention to the first part of that description, the per request part. What this means is the DataLoader only lives and does its job for a single server request. In other words, when the server receives a new GraphQL query, we'll need to create a new instance of the DataLoader and use the DataLoader for the duration of the request. But once the response is sent from the server, the DataLoader instance will fall out of scope and be garbage collected. I bet some of you are thinking, wait a minute, how can the DataLoader do caching if it's so short-lived? Well, you might be falling into a common misunderstanding. It's important not to confuse caching the DataLoader does with caching done by something like Redis and Memcache. The DataLoader library isn't a replacement for these types of cache. You'd use the DataLoader in addition to these types of caches. Okay, so how do we use the DataLoader? Well, first of all, I'll install it by keying npm install DataLoader. Next, we'll open up the review.js file, and I'll import the DataLoader from the DataLoader package. So how do you use the DataLoader? Well, you'll need to create instances of the DataLoader for each new server request by keying new DataLoader and passing it a callback function. Now, to add an ID to the DataLoader instance, you'll call its load method, passing in the ID. Then, after a tick in the JavaScript event loop, all the IDs that were passed into load will be sent to the callback function. Okay, let's do this. In the review.js file, I'll create a new exported function named reviews.dataLoader, which will simply return a new instance of the DataLoader, and we'll pass it a new callback function named reviews_by_book_IDs, which doesn't exist, but we'll create it right now. So I'll create the function named reviews_by_book_IDs, which gets passed in an array of book IDs. Next, I'll just copy the body of the existing review_by_book_ID function, and I'll paste it into our new reviews_by_book_IDs function. Now I'll modify the SQL command, adding a call to the Postgres any function around the $1, and then I'll tweak the params array to include the book IDs, not just an individual book ID. So do you think we need to do anything else with this function? I mean, can we just return the array of reviews that we get from the database from this SQL query? Well, not exactly. Let's say for discussion's sake, the book IDs parameter contained an array of 3 book IDs, 1, 2, and 3. Now let's say the server returned 4 review rows that look like this. If we just returned these 4 review objects to the DataLoader, how would the DataLoader know which books these 4 reviews are associated with? I mean, all 4 reviews could be for one book, or there could be some other distribution of the reviews between the 3 books. But currently, there's no way for the DataLoader to know which review goes with which book, so obviously we'll need to do something so that the DataLoader can know which review belongs to which book. Here's what we need to do to make this work. We need to map the reviews returned from the database to the input array. Here's what I mean. If the first element of the book IDs array is 1, then we should return an array that contains the reviews for the book with an ID of 1 in the first element. And we should do the same thing for book IDs 2 and 3 as well. Now this new array is sequenced so that the data loader can figure out which reviews go with which books. Okay, so obviously we'll need to do a little bit of data manipulation in this function to properly sequence the array we return. Here's how we'll go about handling this. I'm going to use one of my favorite JavaScript libraries named Ramda, which is sort of like a Lodash or underscore, but it better supports functional programming concepts. So I'll import two functions named groupBy and map from the Ramda library. So what does this groupBy function do? Well, let's say you've got an array with 4 book reviews that looks something like this. I'd like to transform this array, which includes the book ID and the review data, into an object where the properties are the book IDs and the values are the array of reviews. Why do I want to do this? You'll see in a moment here. Ramda's groupBy function will do this exact data transformation for you. To get from this array to this object, all you need to do is call groupBy, passing it a function that returns the value you'd like to have the resulting object grouped by, which in our case will be the review book ID. Then you'll just pass in the array to act on, which in our case is the array of reviews. Okay, let's go use the groupBy function. Instead of returning the promise you get by calling the query function, I'll create a new constant named reviews, and I'll set it equal to the value you get by awaiting the promise returned from calling query, and of course I'll need to make this function an asynchronous function. Next, I'll create a constant named groupedById, and I'll set it to the value you get by calling Ramda's groupBy function. I'll skip the first parameter for a moment, and then I'll pass in the reviews array as the second parameter. The first parameter will be a function that takes an individual review from the reviews array, and I'll have it return the reviews book ID. Next, we'll do the mapping of the input book IDs to their corresponding reviews, as we discussed a moment ago. To do this, I'll return the value you get by calling Ramda's map function, and I'll skip the first parameter for a moment, and I'll pass in the array of book IDs to map over as the second parameter. Now, the first parameter should be a function that receives an individual book ID from the book IDs array. Then what's returned should be the reviews for the past book ID, which we can get by keying the groupedById constant we created a moment ago. Then, using bracket notation, we'll access the reviews for the past book ID. This expression right here is why we use the groupBy function. Okay, that's all we need to do in the new ReviewsByBookIds callback function. All right, we're ready to create and use the data loader, but the next question is, where do we use it? In other words, where in our code base should we call the ReviewDataLoader function? Let's head over to the server.js file, and I'll show you. In this simple Node.js server, I'm using the Apollo GraphQL server. We're going to add a new property to this config object named context, which I'll set to be a function. This function will get called every time the server receives a request, and whatever we return from this function will get passed into each resolver function on this server. In other words, this context function will allow us to create a new data loader for every request, and it'll send the data loader into every resolver function, which is exactly what we need. So I'll return a new object with a loaders property, which I'll set to be an object with a reviews loader property, which I'll set to be a new data loader instance. But first, I'll import the reviews data loader function from the review file. Then I'll call the reviews data loader function to create a new data loader. Okay, cool. Now all we need to do is head over to our resolver function and use this data loader that's stored in this context object. So how do we access the context object in our resolver function? Well, it's one of the provided parameters. The first parameter is the book, and the second parameter contains the field arguments, which we don't actually need in this case. But the third parameter is the context object that we need. Next, I'll just unpack the loaders from the context. Then I'll unpack the reviews loader from the loader object. Now I'll get rid of the call to the ReviewsByBookId function, and instead we'll return a call to reviewsloader.load, passing in the book's ID. Okay, that's all we need to do to use the data loader. Let's see how many queries get sent to the database server now. So first I'll clear the terminal, then I'll execute our GraphQL query, and we'll take a look at what was logged in the terminal. All right, last time we ran this GraphQL query, 11 SQL commands were sent to the server, but this time we're only seeing 2 queries. Nice. What if the book query here returned 100 books instead of 10 books? How many SQL queries would be sent to the server in this scenario? Well, we'd still only see 2 queries get sent to the database. The only thing that would change is this list of IDs would be much bigger, as it would contain 100 book IDs. I want to show you one more thing by tweaking this GraphQL query. First, I'll copy the entire books field and its subselection. Then just below the books field, I'll create an alias named books2, and I'll paste in what I just copied, the books field and its subselection. So how many queries do you think will get sent to the database server in this case? Well, let's try and see. First, I'll clear the terminal, then we'll run this query, and we'll check out what was logged. Okay, we see 3 queries. The book query was sent twice, but the reviews query, which is using the DataLoader, was only sent once. The reason the reviews query was sent once is because the DataLoader performs per request caching. So there was no need to query the reviews table more than once. Nice. Hey, if you like this video and you're interested in learning more about GraphQL, you should check out my course, GraphQL for Beginners with JavaScript. It's jam-packed with over 50 videos and more than 5 hours of content that will get you up and running quickly with GraphQL.